In an earlier module, I hinted that we were going to cover the last of the collider options, one of which included used by effectors, which we've already covered. The other two, used by composite and tiled, is what we're going to cover in this video. So first, let's turn off all but one of the cubes. Move it up a bit. Turn off the mesh renderer. Add a composite collider. What a composite collider basically does is make two connected colliders mesh together into one single collider. This is good for otherworldly objects or very non-simple objects that are very complex and otherwise might require other colliders. The downside, though, is that it's very processor heavy. It also has a lot in common with 3D modeling terminology. Let's add another box collider. We're going to move the offset down a bit. Now, as you can see right now, there's visibly two colliders on there. To mitigate this, we're going to turn on used by composite on both box colliders. As you can see, both colliders are meshed together. A composite collider cannot function without other colliders and a rigid body. The first four variables are things we've seen before. Geometry type lets us see the inner workings. Like right now, it's just showing the outlines. If we switch it to polygons, we could see its vertices. Basically, the more vertices, the more processor heavy it's going to be. Which there's only two of them, it doesn't hurt much. Generation type basically affects the vertex distance in very subtle ways. Synchronous is very jaggy if we wanted to edit it. Of course, it depends on how many vertices the collider has, else it'll just disappear. Manual is more of a hands-on approach where to generate each time. It saves a little processing power, but it's not enough. Going back to outlines, there's one more option called edge radius that leads to interesting results. It just increases the edges more to make it bigger, fatter, and harder to dodge or move away from. On the offset, they're not very self-explanatory, but can be an extra hand at the cost of some processing power. Now lastly, we're going to cover auto tiling. First, we need to get rid of the cube and mesh renderer. Auto tiling is a 2D physics exclusive, so it needs the sprite renderer. Let's add the wrecking ball. Recenter it. Switch straw mode from simple to tiled. Check on auto tiling in the box collider. Now, it may not look much, but when we edit the width or the height, it makes more wrecking balls as if it were tiled. Of course, the collider isn't exactly perfect. Let's fix that quickly. This is especially fantastic for tiled terrain. Of course, the wrecking ball isn't the most apt choice for ground terrain, but just showing an example. In this module, we covered area effectors, point effectors, composite colliders, and the auto tiling option for sprite renderer, and how they might be used as hazards and mechanics, and stuff as simple as terrain. Experiment if you need to. In the next module, we're going to dive right into scripting and how we can affect physics through basic coding.